Hello, this is Mr. Liu, and this is an introduction to the first challenge of the year, the Music Waveform Analysis Challenge. So I'm going to brief you on the different parts of this challenge. So going to the website, if you click on Physics, you'll see that under the second tab are the challenges. And the second bullet point here is the first challenge, Music Waveform Analysis. So if I click on that, you'll see the actual assignment. And in a nutshell, what it is, it's an analysis of waveforms for a song that you pick, a bar of music for a song that you pick. You're going to draw transverse waveforms, you're going to draw some longitudinal waveforms in part 2, and then you're going to design your own waveform in part 3. To start you off here, the first part consists of 4 different steps: picking a song, finding the notes in a song, finding the frequencies, and then plotting it. So I'm going to walk you through those steps here. So if I go back to the website, if I click on step 1, the first thing you're going to do is pick the sheet music for a song of your choosing. And this is a website that allows you to print the first page of a song for free. If you have music at home, sheet music at home, that's fine. You can use it as well. If you don't have access to sheet music, this is free. So I'm going to click on Stairway to Heaven, which I think everybody's heard. And you're going to get a page here with the sheet music. And you can, like I said, you can print the first page for free. You want to pick a song that has single notes played at once and also chords. So here, if I look vertically up and down, here's a single note played by itself. Here's another one, another one. Here are 2 notes played at once, which is a chord. 2 or more notes played at one time is a chord, and so forth. And here's another example, and so forth. So the first step is to simply select a song and print the first page. The second step is to write the notes in one bar for the notes in your song. So middle C, D, E, and so forth, in the bass and treble clefs. The next step is to convert the notes into frequencies. So for each note that you write, and again, if you're not, if you don't know how to read music, it's a fairly simple process we can walk you through. For instance, middle C is the frequency of 261.62 hertz, 0.63 hertz. So for each song, for each note in your song, for the bar, you're going to write the actual numerical frequency. So D is 293, F is 349. If it's in the first octave, second octave, and so forth, all the frequencies are noted there. And then finally, once we've selected our song, written our notes, written the numerical frequencies for the notes, we're then going to plot it using an Excel spreadsheet here that you can download. And in a nutshell, what you're going to do is type in the amplitudes and frequencies for each of the notes, and the spreadsheet will then plot it for you. So this is a screenshot here, but I'll show you the actual spreadsheet and give you a demo of it. Here it is right here. You can download this. And this works in Excel, but it also works in OpenOffice, which is a free office type program. It somewhat works with numbers. There are some problems in numbers because the file format's a little bit different. So I'd stick with Excel or OpenOffice. At any rate, what I'm going to do here is to start you off is I'm going to zero out, give an amplitude of 0 to the yellow and the green graphs, the third and fourth harmonics, and I'm going to change the frequency of the red one to 100 to match the blue one. And what you'll see is it plots the actual waves. So here I have the blue has an amplitude of 1, here's the height of 1. The red has an amplitude of 2, which is there, and the purple one is a total signal. So it basically adds those two. So amplitude-wise, if I have a 1 plus a 2, that gives me a 3. And this is done all along the way for all points. Here's 0, so all of them end up at 0, and so forth. If I make this negative 1, this is an interesting case. If I flip the red one around, upside down, I get negative 1 and positive, or positive 1 and negative 1. Those add up to give me 0. And in fact, it gives me 0 everywhere along the axis. That's the purple graph. So it cancels, which is the basis of noise-canceling headphones. Go back here and make this an amplitude of, let's say, 5, and I'll go 4, and 3, and 2. And as I add more waves, and you can see that the purple waveform, which again is just the sum, it gets very interesting. So this is what you're going to plot for each of the notes in your song. Again, here's 261.63, that's a middle C. And that's the red graph. You can see how it changed. Another thing you're going to have to do is adjust the time frame. So this goes from 0 to 0.03 seconds. you're going to have to change that depending on your note. So it's very simple. What I do is I go to the axis, and you can tell when you're there because there's a little text box that pops up that says you're on the x-axis. Right click, and I get a format axis box, which I'll click. And right now the maximum's at 0.03, but I can change it. I'll go to 0.05. And if you do that, you can see the time frame's longer, and therefore I see more waves. So again, in the assignment, you're going to have to be changing this, but it's very simple. Right click on the x-axis, format the axis, and I'll change it back to, let's say, 0.02 now. And it's a shorter time frame, so I see less waves. Going back to the website here. Finally, there's a rubric for all of this, which is a grading rule and where the points are distributed. I'll talk about that in a little more detail in a different video. But these are the first steps you're going to need to get started in the Music Waveform Analysis Challenge.